All right, so I'll get started. Oh, yeah, go ahead. I gotta find my chalk. Here it is.
Dr. Cook, how much is this homework for?
I don't remember right offhand. I think 60 points. That sounds right. Let me look things up here for just a second. I'll have to sign out of this and sign back in. Give me a minute.
It says 60 points at the top.
Yeah, I was I wanted to tell you like how many points there were for homework overall, likely, and just talk about that for a second. Come on. Let's see here. Let's see here. We have 3 tests. Each is worth at least 150 points. 3 quizzes after I got rid of the 4th one, so those are worth 75 points overall. Finals worth 275. 200 of it's from final exam part 1 and B, 1A, 1B, and then 75 points after the Thanksgiving break. Your homework is a total of 150 points. So I've included some bonus points in there also. So I think I gave 60 points of homework before test 1, right? Because I gave a 30 and a 30. And so this one's worth more because there's just one homework for this part of the course. So I gave 60. So I would guess I'll probably have like 50 more points of homework before test 3 comes around, and then a little bit more after that. So there's some bonus points in there, I think. I might actually not collect homework after test 3. I'll still assign some, like recommended, but I might not collect any after test 3. That's possible. So, does that answer your question? I mean, so, okay. All right, so let's get started. Actually, I guess I should probably collect the homework then. You go ahead and. Don't worry about it. I'll stay. It's okay. I'll stay pulling you back. You're fine. Thank you. Thank you. Thank you. So, are there any particular problems in there that you guys would like to, talk more about? Yeah. You don't remember?
The very last one.
The very last one, part D? Okay, I'll try to do something like that. So suppose you're given f of x equals to, say, 13 plus, 8 over the third root of 2x plus 3. All right? And then, what's that? the x's? Oh, I just say y equals f of x, right? And now we solve. So first of all, what am I doing? Let me take a step back here. My goal is find inverse function as a function of y. And so like you said, switch the x and the y. That's what you do if you were trying to find f inverse of x. But I'm interested in f inverse of y. All right, and I'll try to explain more of why that is today. There's a good reason for it. Let's see if I can come up with an example which is convincing of that. But all right, so I need to solve for x is the first thing. So number one, write y equals f of x. Number two, solve for x. How do you solve this for x? Isolate the x, right? So y minus 13 divided by 8, right, is equal to 1 over the cube root of 2x plus 3. Now, what I'm going to do is I'm going to flip both sides. You can take the reciprocal of an equation, which is just a fancy way of saying cross multiply, you know. So this is the same as 8 over y minus 13 equals to the cube root of 2x plus 3. And how do I get rid of a cube root? What's the natural enemy of the cube root? Yeah, the cube function. So cube both sides, exactly. So that gives me 8 over y minus 13. I'll just leave that as cubed. Equals to 2x plus 3. And from that, I can see that x is equal to 1/2 of that cube, 8 over y minus 13, minus 3. So what I did was I subtracted 3 to the other side, and then I divided by 2. And there you go. That's the formula. This is f inverse of y, 1/2 of 8 over y minus 13 quantity cubed, right, minus 3. There you go. What's that? Oh, you got it wrong? Well, I mean, the one in the homework is a little bit. If you found the formula for f inverse of x, I'm going to give you full credit for that. Like, I'm not going to be a stickler for that. That's okay. You know, if you understand, if you still remember from high school, like flip the x and y at the start, you find solve for y instead of solving for x, right? Then what you get is the f inverse of x. Now, the reason I think it's healthy and good to solve for f inverse of y, let me explain my philosophy. So the picture is this, right? We got a domain of f. And over here, the place we're mapping to, the range of f. So if I use x for a typical point over here, and if I use y for a typical point over here, see what happens is f takes me from there to there, but f inverse takes me from there to there. We capture, more specifically, it's not just that, right? It's that f of f inverse of y is equal to y, right? And f inverse of f of x is equal to x. But these are for, I mean, the first one is for y where? For y in the range of the function. But the second one is for x where? right, in the domain of the given function. So let me ask a question. What's the domain and range of this function? Can you tell me what the domain and range is of f? I can tell you the domain pretty easily. What's the domain of f? What's the range of f? Can you guys tell me what the domain of f is? What do you need? We need for the formula to make sense, right? It's a cube root, so we don't need to worry much about that. We can hit it with a negative, that's fine. What's the trouble? It's dividing, right? There's a division. So we need to worry about that cube root working out to 0. How can that happen? Well, it has to have an input of 0, right? How can we get a division by 0? We would need 2x plus 3 equal to 0. So what's the domain of f? It would be x such that x is not equal to what? I think minus 3/2, right? X not equal to minus 3/2 would be the domain. If you wrote it in interval notation, it would be minus infinity to minus 3/2 not included, then minus 3/2 to infinity included, right? I keep asking you guys to write stuff in interval notation, don't I? So I guess you probably would expect this, right?
I think when I solved mine, I did it like that, but like at the end, I changed it to x instead of y.
Oh, that's fine.
I understand what you're saying though.
Right. So, but my question is, this part so far is easy, right? Like, you guys can find the domain. If you understand the domain problem, I think most of you have a pretty decent chance at telling me that the domain is all x except for minus 3/2, right? But how about the range? What's the range of the function? How have I explained to you how to find the range of a function? What have I told you to do? I haven't really given you an algorithm for that, have I? For the domain, we look for division by 0, we look for the square root of a negative number, fine. The algorithm for finding the range of a function is pretty much just graph it. If you can graph the function, you can see the range from where the y values are attained, right? Can you graph that function? I mean, you can, but it would take you a long time, right? You'd need technology. I do not need technology to tell you what the range of this function is. You know how I know what the range of the function is? I know what the range of the function is because I understand that the range of the function is equal to the domain of the inverse function in the case that the function's invertible. And domains are easy, right? I can figure out what the domain is of the inverse function. What's the domain? Look at this. What's the domain of the inverse function? It's y such that what? What's the one thing we can't do in that formula? Can't have 13, right? Because we'd have division by 0 if we had y equal to 13. So I can tell you what the range is. The range of f, it's just minus infinity to 13, not included, with 13 to infinity. There you go. That's the range of the function without so much as an ounce of graphing. This is something I just learned this week, to think this way. It just occurred to me. Like, I've not been doing this. But it's also limited, right? Like, this trick only works for what kind of function? Invertible functions, right? If the function's not invertible, you're still back to graphing. It's no help. I guess we could check our work, right? Oh, come on. I will use the Wolfram Alpha. Oh, no, wait a minute. I'm going to use Desmos. What am I doing? Desmos is easier. Prettier, too. So what was our function? 13 plus what? 8 divided by cube root. I'm going to do parentheses, the third power instead of, all right, so 2x plus 3, close parentheses, raised to the 1/3 power, right? The cube root is the 1/3 power. My syntax is funny. All right. Come on. Whoa. Look at that. Can you guys see it? Did you okay, cool. Wow, look at that. See where it doesn't go? I mean, you got to use your imagination a little bit, but if I were to add it, if I was to perhaps add a y equals to 13, you could see it better. See it? Right there? Y equals 13 is the one value that the range doesn't hit. See, even if you were using technology, if you weren't careful, if you started out like this, you might be tempted to think, oh, the range is everything, right? But if you zoom out, uh-oh, there's a feature. There's this thing missing. But anyway, anyway. Oh, and this costs how much money? $0, yes. You know, you can also get emulators of like Texas Instrument calculators for your, if you have like an Android phone or something. My brother typically will show his class, hey, look, I've got a TI-89. I've got a TI-80, whatever you want. You can emulate it on the Android phone. I'm sure that those are probably not approved of by Texas Instruments, but I don't know. Whatever. How is Texas Instruments still selling a calculator for $150 at this point, by the way? Like, I don't understand that. I mean, that, if you want an example of a monopoly in economics, like, I think graphing calculators are probably a pretty good example. Anyway, any questions? Okay, let me put this away. Let's see here. So, just another example. Slash discussion that I should have with you. And I've had with some of you this discussion individually, but, you know, why is it, what's the difference between the cube root and the square root, right? So here's the graph of y equals x squared, right? What if we tried to make this, you know, what if this was actually an invertible function? We could graph the inverse from doing what? How do you graph the how do you take the graph of the function and get the graph of the inverse function? Let me make it a little bit steeper. So like this point would be what? Like something like minus 2, 4. This point over here, 2, 4, right? If that's my function, what corresponding points, and here's the origin, what corresponding points do you get on the inverse function? We go to what? 4, 2, right? And this one goes to what? 4 minus 2, right? The origin, still the origin, when you flip the x and y coordinates, right? So if we were to try to graph the inverse alleged function of the, in a parabola, or the function f of x equals x squared, you see we get into trouble, right? So in other words, y equals x squared, it maps to what? When we flip x and y, we get x equals to y squared, the green, right? The sideways opening parabola. And is that the graph of a function? No, right? So what do? Because we want an inverse to squaring, so how do we fix it? Yeah, we limit the domain of the square function to just be positive, is what we do. So essentially, we just say, okay, well, we're going to just say this is what we're going to look at. Y equals x squared. That's my f of x for x greater than or equal to 0. And then this is the inverse function. Y equals f inverse of x, square root of x. And I mean, this is a good example of inverse function, right? Because f of f inverse of x is what? F of the square root of x, which is what? Square root of x squared, right? Which is just x again. But what is f inverse of f of x equal to? It's f inverse of x squared, right? Which is the square root of x squared. What's the square root of x squared? Well, in this context, it's just x again, right? But more generally, we know there's like a formula for the square root of x squared. That's the absolute value of x, all right? Like that's a formula for the absolute value of x, is the square root of x squared. But here, since x is what? Since x is non-negative, right? The absolute value of x is just equal to x again. So that goes to show you that, the square function and the square root function are inverse functions. But there are terms and conditions to that, right? Like that is for non-negative inputs. Now the squared function has a larger interpretation, right? You can take an equation where you have negatives on both sides, right? And you can square that equation. It's not a big deal, right? We do it all the time. We take an equation, we got a negative on one side or the other, we square both sides, we find a new equation. It's something we've done to remove radicals in here before. In contrast, when we take the square root of an equation, there we got to be careful, because if it's negative, then we might be leaving the realm of the algebra that we understand. What's interesting is that when you switch from squared to cubed, this doesn't happen. When you look at y equals x cubed, this story doesn't play out the same. So if I look at y equals x cubed, so think of that as being my function, right? I can track some points maybe. I never draw the stupid graph the way I want it. Need to make it steeper. So maybe this point here is like -2, -8, and this point up here maybe is 2, 8, right? If that's the function, we want to graph the inverse function. What do? We flip the x and y coordinates to make the new graph, right? So this on the inverse function gives me 8, 2, which is like over here somewhere. And it would be better if I had, well, if I was like a lot taller, that would be helpful. And then it's over here somewhere, right? -8, -2. the origin stays put, 0, 0 maps to 0, 0 under this transformation. And so you see that the graph of the cubic looks something like that. It doesn't run into the same trouble that the square did, does it? So what this shows you is that f inverse of x, in fact, we call the cube root function. In other words, I mean, the equation for the green graph is just x equals to y cubed, right? Whereas the equation for the white graph is y equals x cubed. So you just switch the x and the y, and that gives you the inverse as an equation, right? But then, of course, if I solve for y, this gives me the cube root of x. And so the fundamental thing is, if we have the cube root of x cubed, we get x again. If we have the cube root of x cubed, we get x again. Stupid English. It's just the parsing of the words that's actually different, right? Like the cube root of x cubed versus the cube root of x cubed. It's unfortunate the way English works for the sentence, mathematical sentence, isn't it? So the cube inside versus the cube outside. This is why parentheses are important, because they allow us to say something with symbols that's hard to capture with a sentence. So, but the thing is, these are both for all x in the reals. There's no string attached to this one. Really big difference, right? I don't think we emphasize this enough in algebra courses, right? You're like, well, would have been nice if you'd emphasized this before you just collected that homework where there was a cube function in it that I didn't know about. Sorry.
Is the same principle apply to like all even and odd?
Yes, yes. So what we have is that the 2nth root of x to the 2n power is equal to the absolute value of x. Whereas the 2n minus 1th root of x to the 2n minus 1 is just equal to x again. So, and vice versa, if you take the 2nth root of x and raise it to the 2nth power, you get x. If you take the, I really could use like another chalkboard right here. I think I've got a technology survey I'm supposed to fill out for the university. I'm going to put on my technology survey more chalkboards. That's what my 3-year-old says to my wife. Order more. It's usually Play-Doh. But he's watched my wife. He's learned that you go to that Amazon site and you order more, So he's well aware of commerce, the appearance of new toys. Let's see here. So, I mean, we could just say any nth root of x raised to the nth power gives us x again. It's just that, well, this here, in order to put x into here, we need x is not negative, right? Otherwise, it's not in the domain of the even function. But yes, and in short, to answer your question, yeah, this pattern continues for that one for 2, 4, 6, 8, whatever, and for this one for the 3rd, the 5th, the 7th. In fact, the most basic case of this, which I didn't even mention because it seems like too simple to be relevant, is y equals x. If we have f of x equals to x, what's the inverse function? F of x equals to x. Find inverse. Here, you work that out. Work this example out while I'm erasing everything else. Oops. I think I may have made that shirt slightly too wet. What'd you get? What's F inverse of Y? What's that? Same thing? I should have brought a drying shirt. Well, this shirt really doesn't absorb much. Well, I can see it. It's drier. You can't see it, but I can see it. Oh well, whatever I write on here is perfect. So, number 1, you said y equals x. Number 2, solve for x. Number 3, f inverse of y equals y. Yeah. This is a very silly example. F of x equals to x is its own inverse, right? If you take, what happens when you calculate f of x? See that? F of x is equal to x. That shows you that f is equal to f inverse. So, just like the cube, no terms and conditions. But this is actually a special one. This has a name. This is called the identity function, right? And this is a function you can write on any set. Like I could look at the set of students in this room, and I can talk about the identity function. Like the identity function acting on Michaela is Michaela, for example. Identity function on Aaron is Aaron. It's a very boring function.
Wait, which one?
The identity function. It just says whatever you give it, it gives you back the same thing.
That's on the test?
It's a very silly function. What's that?
On the test?
Is it on the test? I mean, I guess I could put it on the test. I don't know.
Well, you haven't made the test yet?
Huh?
You haven't made the test yet?
Oh, no. I like to keep excitement in my life. I always make tests like right before I give it, because I like the thrill of whether or not the printer will work, that sort of thing. Keeps it interesting. As a stapler.
That'll be good.
Yeah, that's my.
Which printer do you use?
Which printer do I use? I like you guys. You have hilarious questions.
The one in the office. I was for
For real, what?
that man on the test.
I mean, it's possible, I suppose. But hey, an example.
30-point bonus question, that question right there.
An example I've shared with some of you individually. So my apologies. This is a little bit of I'm recycling an example that I've shown some of you individually, but I think it's healthy for everyone to see it. And it's kind of like your homework, but it's kind of not. Something like this. I'll change it up a little bit. 1 over the square root. Oh no, I don't. Nah. Let's see here. Suppose we had f of x equals the square root of 2x minus 10, and g of x equal to the square root of 3 minus x. Right? And so what I'm going to do is I want to find what's the domain of f plus g, and let's see, find formulas and domains for f plus g, f times g, f divided by G and G divided by F. If we wanted something more challenging, we could also try to find the domain of F composed with G. That one I haven't done yet with you guys. Let's do that one too. Okay, so, man, I really got that shirt too wet. Things take forever to dry. What's the domain of F? We need what? We need 2x minus 10 what? To be what? Greater than or equal to 0. So that's 2x greater than or equal to 10, which is x greater than or equal to 5. So apparently the domain of F is what? Right, so that's 5 to infinity in interval notation, right? What's the domain of G? What do we need? We need 3 minus x to be greater than or equal to 0, right? Which is 3 greater than or equal to x, which I prefer to write as x less than or equal to 3. What's that in interval notation? Domain of G is what? Great. So, what's f plus g of x? So we just take the formulas, we add them, right? And how about the domain? We have to think about what? We have to think about the domain. Domain of f plus g is what? It's the intersection, right, of the domains of f and g. So I draw a picture. I put 5. Uh-oh. Ha-ha. Well, this is actually an interesting problem, isn't it? So here's 5. And there's 3. I'm actually very happy with the way this turned out. It's kind of I mean, if the first time this happened was on the test, that would be pretty nasty.
What, that right there?
Mm-hmm.
That one.
Because
So let's not put it on the test.
what's the answer? I mean, I would say the right answer here is that you can't add these functions because they don't have any common domain. What's the intersection of two sets which don't overlap? Right, I mean, there's no real solution essentially, right? This is what's called the empty set. Or some people write it like this. It's the set containing no elements. So, I mean, essentially, this formula never makes sense as a real number.
So how would you want to strive this one through as the empty
Oh, hopefully I wouldn't put this on the test because it really wouldn't tell me much. This is a great question to separate my A's from my A pluses. But everybody else, I'm just going to have noise in the grading. This is not the question I would want to ask on a test. I mean, maybe it's like a bonus, but that would be, yeah.
This is something that you can get.
Now we could fix this, right? I just need to change that 5 to a minus 5. How do you change that 5 to a minus 5? Plus 10. We have a winner. Yes, plus 10. Just make this a plus 10. Then that makes this a minus, and makes this a minus, makes this a minus. Plus. And like this instead, right? Now we're in business. So between minus 5 and 3, there's an intersection, right? What's the intersection now? So instead of being empty, it's minus 5 to 3. You know how people sometimes say we just need to agree to disagree?
Yeah, I've heard that.
I mean, it's kind of like a lost art these days.
What, agree to disagree?
Yeah, people don't really have agree to disagree anymore. It's more like either we agree or I will vilify the other side. And I think that's generally true for most of everybody. But so I mean, the original functions, they can't even agree to disagree. They can't even agree to have a conversation. There's not even any two x's which the two formulas can even both talk about. You know, they're just. But these here, both these formulas make sense from minus 5 to 3. So that would be the domain of the sum. It would also be the domain of the product and the difference. All right. If I have fg of x, that would be square root of 2x plus 10 times the square root of 3 minus x. There you go. And domain of f times g is still minus 5 to 3. Now here's where it gets interesting. If we have f over g, or if we have g over f, f over g is square root of 2x plus 10 over the square root of 3 minus x versus square root of 3 minus x over the square root of 2x plus 10. So what's the domain of f over g versus what's the domain of g over f? So for the quotient, we need both the numerator and the denominator to make sense, right? That's already given to us if we're somewhere in the closed interval from minus 5 to 3, right? But now we have something new to worry about, right? What's new to worry? Yeah, 0 being the denominator, right? So for f over g, we got to worry about 3. 3 is trouble. So we have to exclude 3. We can include 5. That's no problem. It just makes the numerator 0. And on the other hand, this one, we need to exclude minus 5 because it makes the square root of 2x plus 10 be 0. Square root of 0 is 0. And we can include 3 because that just makes the numerator 0. That's not a problem. So I like this example. I think it has a lot of the interesting aspects of that discussion. See, that's the bad thing about. See, this is why you shouldn't write on wet. See now. Well, I'm not sure class is long enough for us to use this board again. We'll try. We have to 120 though, right?
110.
Oh, 110. Oh, right.
We started 12:20.
I know.
Don't dig a hole for me that I can't get out of.
I'm tempted to just be quiet to see where this goes. I don't know. Okay, so this other one, f composed with g. I have not talked about really how to find the domain of that. But we can fall back on our more basic principles, which is what? Find the formula, right? And see if we can make sense of it. So that's f of g of x, right? Which is what? Did I hear it? Mm-hmm. I'm starting to think you're just saying mm-hmm. Let's see here. Nice. All right, so that's 2g plus 10, I believe. Wait a minute, no. Yeah, square root of 2g plus 10, right? That's the formula for f if I put g in the place of x, right? And then that's what? 2 times the square root of 3 minus x plus 10. So there's the formula for the composite. Now the question is, you know, what's the domain of that thing? So just again, I'll write it down here. F composed with g of x, we just worked it out. It's the square root of 2 times the square root of 3 minus x plus 10. So the same general principles that I've already shared with you apply. This is probably just a little bit harder, right? First of all, I'll start with the easy thing. We definitely need 3 minus x greater than or equal to 0, right? Because we need this to be real, right? So 3 minus x, in other words, what? X less than or equal to 3. That's one condition that we need for our domain. What else do we need? We need all of this to be non-negative, right? So we're going to have to solve 2 times the square root of 3 minus x plus 10 greater than or equal to 0. Can we do that? I think you actually already have the tools to do it. I don't think we've done a problem like this before. So you just got to use the basic laws of algebra and inequalities that we've discussed, right? So this would be 2 times the square root of 3 minus x greater than or equal to minus 10. And so that would be the square root of 3 minus x greater than or equal to minus 5. Let me write that a different way. Minus 5 is less than or equal to the square root of 3 minus x. What x solve this? Think about this. Yeah, which x solve this? Let me write something else. This is minus 5. Minus 5 is less than 0, right? And 0 is less than or equal to the square root of 3 minus x. Which x solve this? What's that? The addition one? No, easier than that. I mean, so basically construction of the square root function makes it non-negative, right? We just need that minus 5 is smaller than the square root. That's automatically true for the square root, provided the square root makes sense, right? What do we need for the square root to make sense? The thing we already found up there, x less than or equal to minus x less than or equal to 3. What I'm trying to tell you is the domain for this function is just given by x less than or equal to 3, because it just so happens that what's inside the square root here is automatically positive. Hooray. You could imagine another example where you actually had some kind of limitation from this part of the problem, you know? But listen, I don't expect things like that. I mean, there might be one thing like that on the test as like a bonus question, but it wouldn't be the bulk of the test. The bulk of the test will be like your homework, right?
Like the first problem of our homework?
The first problem. What was the... I feel like this is a trap.
That's not
Yes, like the first problem. The first problem in your homework is a very likely example of a test question. Yes. Yeah. 24. Problem 24. Thanks, guys. I was about to say have a good weekend, but I think I'm